What's up, math fans? Today I want to solve exponential equations using logarithms. So you've already seen my videos on basically everything there is to know about logarithms. For example, the rules, the quotient rule, the product rule, and most importantly, the power rule. All right. You've also seen how to turn an exponential equation into a logarithmic equation. So you're good at manipulating it. Hopefully you memorize some formulas. But really, if you want to understand why you're using logarithms, they help you solve for unknown exponents, because guess and check might take too long. If you want an exact value and quickly, then logarithms are going to help us, okay, and you'll see how in a second. But as a warm-up, if you're dealing with exponential equations, so here's an equation where I have exponents, but the base is the same, then I don't need logarithms. That's just basic. If the bases are the same, you can now conclude that the exponents are also the same. So I'm going to ignore the bases and just write x minus 2 equals 2x minus 6. So that's simple, basic. You probably knew that already. I'm going to subtract x from both sides, and at the same time, to save time, I'm going to also add 6 to both sides. So this is gone. That's a 4, and this is x, and that's gone. Look at that. I'm done. X is 4. And you can check my work by substituting in the original equation. Now, let's look over here. Again, it's an exponential, but if you can make the bases look the same, like here the bases were the same, then I don't even need to worry about logarithms. So, can I rewrite 16 as something with a base of 4? I sure can. 16 is really 4 squared. Alright? Everything else drops down. 5x minus 1 over here. And if you remember, a power to a power means you multiply those exponents. So now that I have the bases equal to each other, I can kind of do the same thing here. I just conclude that the exponents equal each other. So 4x plus 4 equals 2 times 5x minus 1. All right? And again, basic algebra will get you an answer. So let's see, what is that? 10x minus 2 equals 4x plus 4. I'm going to subtract 4x on both sides and add 2 on both sides just to save time and space. So here I have 6 equals 6x, and hopefully you know divide by 6 on both sides to get x equals 1. Okay? And again, check your work by plugging in the original equation. Those are simple. I don't need logarithms. But here, 3 to the what gives me 12? I don't know. Can I rewrite 12 with a base of 3? I can't, because I know my powers are 3. 3, 9, 27. I'm already past 12. So I can't use this basic stuff over here. That's where logarithms come into play. Here is a reminder of the power rule, which is a video you've probably seen recently. If you go to the end of this video, I've actually figured out some kind of technological trick to put links to my videos that you should have seen before this one. Alright, so let's see here. Also, a nice hint is, don't wait for me to do it. Press pause, do it. You're going to need a calculator. I'm going to go run and get a calculator and work with me, okay? Check my work. So let's see here. A basic trick for algebra is if you know what you're doing, you can do whatever you want as long as you do it to both sides of the equal sign. So I'm going to do log to both sides of the equal sign. I'm going to take the log of 3 to the x equals, and I'm also going to take the log of 12. Please remember or note, if I take the log and I haven't written a base in that bottom corner, see how there's a little base here, b? If I haven't written a base, then the base can be assumed to be 10. That's called a common logarithm. And if you look at your graphing or any calculator, if it says the button log with no base on it, that's base 10. So let's see here. Now I'm going to use, I have a power, so I'm going to use the power rule, which says if I have an exponent on my logarithm, I can rewrite it as the coefficient. So this x that was the exponent is now the coefficient, okay? And that equals 2 log of 12. Now a lot of people think to divide by 3 on both sides. You're dividing by the entire log of 3. You're dividing by the entire log of 3. Do not do 12 divided by 3. Log of 12 divided by log of 3 is not 4. You're doing it separately, okay? So this is going to cancel, and x is going to equal whatever log of 12 divided by log of 3 is. And I'll let you log 12. Don't forget to close the parentheses after the 12, okay? because the calculator automatically opens parentheses. Don't forget to close them. People get frustrated. You open, you close. They are a pair. And then, of course, divide by log 3. So let's go log 3, close parentheses, and you should get 2.26. I'm going to round to the nearest hundredth. So that's approximately 2.26. Let's go again. Same question. I want to get B alone, but there's all these distractors. So you're going to do what you did in algebra, basic algebra. Get rid of the distractors. If I had, let's say this was 2x plus 10 equals 815. How do you get rid of the plus 10? It's the same thing you're going to do now. I'm going to subtract 10, inverse on both sides. And now I have, now I have 2 to the b power equals 805. How do I get rid of that 7? Do I do 7 times 2 is 14? No, you can't multiply a coefficient and a base. They are separated. If you remember order of operations, PEMDAS, you're supposed to evaluate what's here first. You evaluate the exponent first. But I can't, because I don't know what the exponent is, so you can't just skip it and start multiplying. You cannot. So we're going to get rid of the 7 by dividing by 7 on both sides. All right, you're not doing 7 times 2. So I'm going to do 805 divided by 7. And that gives me 115. So 2 to the b power equals 115. And then we're going to, well, we're right back to what we did up there. I'm going to take the log of both sides. I wonder if you can see that. If you can't, then I'm going to rewrite it for you up here. Okay? So I got the log of 2 to the b equals the log of 115, and I'm going to use my power rule again. So you're going to see a theme here. Log, power rule, log, power rule. So now I have, now I have b times log 2 equals log 115. Guess what I'm going to do? Divide by log 2, divide by log 2. And b equals whatever this divided by this is. And I'm going to let you figure that out. So please, in the comment section, give your friends the answers. I don't know what that is. Number 3, I summarized the word problem. So let's say the word problem is my present value means I have $2,000 right now. I want to invest it in some kind of account, a bank account, where there's 5% interest compounded annually. I generally do examples where it's compounded annually, although I have explained how to compound quarterly or something like that. But to make it easy, we're going to compound annually. My future value, the money I want, is $2,500. So what do I need to know is how long it's going to take to get this money at this rate, starting with this amount of money. So there was a formula you learned. It was called present value equals It was called future value equals present value times 1, that represents 100%, plus the rate that you've put the money in for to the x power, and I define x as the number of years. If it's compounded annually, x will represent the number of years. All right, so knowing how to manipulate logarithms is very helpful when you want to know investment opportunities, bank, interest rates, stuff like that. And I know a lot of times the computer or the banker does it for you, but it's very helpful to know your own stuff. Keep track of your own money. All right, so let's just plug in numbers now. I want $2,500 in the future. I have $2,000 now, and I'm going to have 1 plus the rate. The rate is 5%. You make that a decimal by moving that percent sign over twice. Fill the hole with a 0. This becomes 1.05 to the x power, where I'm trying to find x. Well, I got a bunch of stuff distracting me. Let me get rid of the 2,000. So now I want to see what 2,500 divided by 2,000 is. And that gives me 1.25. Kind of like saying I want 1 1/4 of my money back. Equals 1.05 to the x power, drops down. Now I'm going to do what I've been doing. Take the log of both sides and use the power rule. I'm going to do it all in one shot now. So log of 1.25 equals x times the log of 1.05. See what I did there? I was supposed to put it up here, but I know the power rule says I can write it as the coefficient. And now I want to get x alone. So the more you practice this, the smoother the transitions become. Log of 1.05. And again, this time I'll do it for you, because I don't want you to feel like I left you hanging. So let's see, log 1.05 or log 1.25, close parentheses, divide by log 1.05, close parentheses, and that gives me 4.56. 4.56. So I would need to leave it in for at least 4.56 years. Generally, what that means is you would have to round that up and let it finish the year. So 5 full years, how long you leave your money in order to get $2,500 back. All right, any questions, comments, please leave it in the comment section. Thanks for watching. See ya.